Good morning everyone. I am Dr. V. Vijayasaro. I am currently working in Electronics and Communication Department at Guru Nanak Institute of Technology, and I have completed my UG in Electronics and Communication Engineering in 2010, and I have completed my Embedded System Technology in PG, and I took IoT stream for PhD. Now today's class I am going to discuss about combinational circuits. In combinational circuits I am going to implement the full adder using 3:8 decoder. Before that I have to give short introduction about what is combinational circuit, what is difference between the combinational circuit and sequential circuit, and I have to focus on how to design a combinational circuit. For that I will give example for half adder, full adder as well as the decoders, and I will implement the full adder using 3:8 decoder. First we have to focus on digital electronics. Where we are using the digital electronics in our day-to-day life, we are using digital electronics everywhere in real-time application. For example, in our mobile phone, in calculators, in TV, in washing machine, in cameras, everywhere we are using the digital electronics applications only. So we have to focus more on digital electronics application. For that we are having two types of circuits in digital electronics. They are combinational circuits and sequential circuits. As we know, combinational circuits, we have to give the inputs A, B, C. So output will be in n number. So we have to give the input, output will be retrieved from the present state only. Combinational circuits output depends upon present state input only. But in sequential circuit we have to focus on previous state output also. So this is the sequential circuit block diagram. Here we are giving some inputs, that's the output will be retrieved with the help of the previous state output also. So combinational circuit we are not having any feedback system, and combinational circuit does not require any memory. But in sequential circuit we are focusing on previous state output also. So we have to give the feedback system. So for sequential system memory is needed. It is clear what is the difference between combinational circuit and sequential circuit. I will repeat. Combinational circuit output depends upon present state input only. So we don't need any feedback system or memory path. But in sequential circuits we need feedback system, because output depends upon present state input as well as the previous state output. So we need the feedback path. It is clear what is combinational circuit and what is sequential circuit. Next topic is we have to design the combinational circuit. While designing the combinational circuit we are having 6 important points. We have to measure with, we have to do the 6 points. For example, if you are going to design a combinational circuit, first we have to define the problem statement. I have to add 2 bits means I have to do half adder. I have to do 3 bits addition means half subtractor. If you want to decoder, you have to write what we have to do. Then we have to give what are the inputs and what are the outputs. For example, half adder will perform 2-bit input addition. So we need 2 inputs and we need 2 outputs. Like that we have to mention what are the inputs we need, and we have to assign the inputs values. Then we have to go for truth table. We have to derive the truth table, and from the truth table we have to reduce as an expression by using K-map, and then we have to go for logic diagram with that expression. First I will do with some small examples. So what are the combinational circuits application examples? Half adder, full adder, half subtractor, full subtractor, decoder, encoder, multiplexer. Here I am focusing on small one, half adder. First we have to define what we are doing. So we have to design a half adder to perform 2-bit addition. So here we are having the block diagram. We need 2 inputs and outputs will be sum and carry. This is our first 3 steps. I have defined what is the problem stated and I have assigned what are the inputs we need and assigned the inputs. After that we have to go for the truth table. So we have to perform the normal addition. For example, 0 plus 0, what is your value? 0. 0 plus 1, 1. Plus for 1 plus 1 it will be 10. So your sum value will be 0 and carry value will be 1. So for 0 0 our output will be 0 0. For 0 1, 0 plus 1 it will be 1, carry will be 0, 1 plus 0 1 and carry will be 0, 1 plus 1 our sum will be 0 and carry will be 1. This is my 4th step of designing the combinational circuit, and my 5th step I have to draw the K map and I have to derive the expression. As we all know, in K map we are having 2 types, sum of products and products of sum. Here I am going to use sum of products. So that this is 2 variable K map. So I am assigning A, B, 0, 1. 0 indicates A bar and 1 indicates A. Similarly, B bar, B. Now take the sum output. What is the place value here? 0, 1, 1, 0. So we have to write the expression. Sum is equal to, here we are having A B bar plus A bar B. So sum expression will be A XOR B. Similarly we have to do for carry also. So carry is equal to AB. What is my next step? Last step, we have to draw the logic diagram for this expression. Is it clear how to design a combinational circuit? It is a small example. Now we have to design for full ladder and we have to implement that in 3x8 decoder. So for designing a combinational circuit, first we have to state the problem and we have to define how many inputs, how many outputs, and we have to declare with the symbols. After declaring, we have to derive the truth table. After deriving the truth table, we have to get this expression using K map. After getting this, we have to draw the logical diagram for this expression. Now it is clear. Then we will go for implementation of full ladder using 3 to 8 decoder. Here first we have to define what is full ladder and what is decoder. Full ladder is nothing but it will perform 3-bit addition, and decoder is a multiple input multiple output decoder, and it will convert one coded form into another coded form. So for this I have to mention how many inputs. So we need 3 inputs and 2 outputs. After declaring inputs and outputs, we have to frame the truth table. So 3-bit truth table, it will from 000 to 007. normal addition we have to do. As we know, 0 plus 0, 0, 0 plus 0, 0, 0. Here 0 plus 1, 0, 0 plus 1, sum will be 1, carry will be 0. Again here also sum will be 1, carry will be 0. Here 0 plus 1, 1, 0. So 1 plus 1, sum will be 0, carry will be 1. Here again 1, 0. 0, 1, 0, 1. 1 plus 1, 10, 10 plus 1, 11. So we are having both sum and carry. After framing this truth table by performing the normal addition, we have to derive the expression by using K-map. Here we are having 3 inputs, so we have to go for 3 variable K-map. So I am first assigning the 3 variables and then I am giving the values. If it is 0, A bar, and it is 1, it is A. Similarly 0, 0, 0, 1, 1, 1, 1, 0. So B bar, C bar, B bar C, B C, B C bar. Now according to place value we have to write. So place value 0, 1, 2, 3, 4, 5, 6, 7. Now I am deriving for sum. So 0, 1, 1, 0, 1, now we have to assign each value. So sum is equal to, what is this value? Here A, B bar, C bar plus here it will be A bar, B bar, C, and here it will be A, B, C, and here we are having A bar, B, C bar. Okay, now we have to arrange according to the same bits. For example, here see I am having A, B bar, C bar, and I am combining this both. So B bar, C bar will be common, A plus A bar will be different. Like that if you do, our output will be A XOR B XOR C. Similarly, we have to derive for carry also. If you are having the adjacent bits, we have to group that each other and you have to name the common term. For this term it will be, here we are having common as A, C, this term will be B, C, and here also we are having as A, B. So your carry expression will be AB plus AC plus BC. Like this we have to derive. Apart from that, for implementing in decoder, we have to write the min terms and max terms also. So for sum, what are the min terms we are having? 1, 2, as well as we are having here 5, 7. For carry, 3, 5, 6, 7. Now we have to implement the decoder. For implementing the decoder, we need the formula as n is to 2 power n. Here we are having 3 bits, so 3 2 power 3, so 3 is to 8 decoder I have to design. As I said before, we have to define what we have to do. So here I have to implement the full adder using 3 is to 8 decoder, and here I need 3 inputs and 8 outputs. Now I have to implement in decoder. First we have to draw the decoder structure. So here we are having 3 inputs and we have to give enable pin. If enable pin is 1 only, then output will generate, otherwise our output will be 0. So if we are giving enable pin as high, and we will get this output. Now measure, now round term we for sum we are having first bit, second bit, fifth bit and seventh bit, that is your sum output. Similarly, we have to take the min terms for carry. They are 3, 5, 6 and 7. So like this we have to implement full adder in using the decoder. First we have to define what are the inputs and what are the outputs. After that we have to derive the truth table. From truth table we have to derive the take the min terms, and that min terms have to be included in sum and carry bit. It is clear? Thank you for this opportunity.